We've already found out how to find the area between a curve and the x-axis, but sometimes you're going to be asked to find the trapped area between two curves. Like in this case, you could be asked to find the trapped area between g of x and f of x. In that case, all you have to do is understand that there's going to be an upper curve and there's going to be a lower curve. Now, if you look at this part is basically the upper part, and then this part right here is basically the lower part. And so what you do is you basically find out this area right here, and then you find this area right here. I'm just going to change color, this area right here, and you subtract the two, and you will get that red area right there. So how do you do that? How do you find these areas? Well, all you got to do is first, after you've identified the upper and the lower curves, all you got to do is you got to find the right limits. So what are the right limits? Well, let's say I take these 2 points as my limits. Now you can kind of extend these as lines. You can kind of extend these points as lines. And you could see, well, okay, if I find the area of the upper curve between these 2 points, my upper curve is going to look something like this, and then my lower curve is going to be something like this, and these sides as well. So you can clearly see these are not the right limits, these are not the right bounds. I need different bounds. Why? Because I don't need this area right here and this area right here. So what do? Well, we take different bounds. And what I'm going to do is I'm going to go ahead and check out these 2 points. So I have these 2 points. Now if I extend these 2 points, I can see that now my upper curve is going to have this area right over here, and my lower curve is going to have this area right over here. And then I could actually subtract both of these areas, and I will get that trapped area I want up there. So I've identified my upper curve, and I've also identified my limits. Now I can actually go ahead and find out the areas. But before I do that, I want to let you guys know that it's not going to be this easy. Because when you have the limits, you're obviously going to need the x coordinates of those limits. So let's say this is going to be A, and that is going to be B. And you're trying to find the areas between A to B. Now, the A and B's may not be given to you, right? On the x-axis, let's say this is equal to 2, let's say this is equal to 3, but that may not necessarily be given to you. And this is where you're going to be using a lot of coordinate geometry. And what you have to realize is you have to realize that this blue curve is basically intersecting this green curve at these 2 points. And so you have to solve a simultaneous equation system to get these 2 points A and B. But that's coordinate geometry, that's not integration. We're here to do some integration. So you identify the upper and lower curves, which we've done. You identify the limits, and then obviously you solve the simultaneous equations to find the limits. In other cases, you're going to have to do some other coordinate geometry stuff or something else, but it's not going to be easy. Finding the limits is not going to be an easy thing when you look at the questions. So then you go ahead and you find the limits. Now once you've done that, all you got to do is you got to integrate. This is where the integration part actually comes in. And we already know how to integrate. So what we were doing was, remember, we had this area that was under the upper curve. So we're finding that's what we're finding. So we are going to, how do we find the area under the upper curve? Well, we just sum, right? We just sum the area of tiny, tiny rectangles. And what's the area of tiny, tiny rectangles? Well, it's this thing right over here. And from where to where? From A to B. And then we are subtracting this area right here under the blue curve. And so we are subtracting this area right over here under the blue curve. So what is the area under the blue curve? Well, it's basically the sum of tiny, tiny rectangles. So the sum of the area of tiny, tiny rectangles. From where to where? From A to B. And this, when you solve this entire thing out, you are basically going to get the trapped area.